Good morning again, and welcome to our first fall PTV talk session. Today we have PTV expert Sean Fitzgerald and Bill Cisco with a presentation on pickup and drop off in PTV VISSIM. First, just a couple of items before we get started. Our PTV talk sessions are recorded and will be sent in a follow-up email. At the end of the session, we will have a Q&A. Some important dates to come up. We have our next PTV talk session on our latest released products. These sessions will introduce PTV flows on September 28th and PTV lines on October 5th. These sessions will be emailed separately to register. Next, our 24th annual user group meeting is right around the corner. This meeting will be held in Orlando, Florida this year. This meeting is an event of the year and is great for professionals to network and learn among industry professionals. We have 2 full days of technical training workshops and 2 full days of networking, user presentations, and what's to come in PTV. Early bird registration ends September 25th, so secure your spot and join in the fun. You can visit ptv.to/UGM 2023 for more information. If you are interested, please join our next web-based training courses. We have VisWalk Pedestrian Simulation on October 5th and VSUM Roundabout Modeling on November 1st. You can find out more information about these trainings, pricing, and registration at training.ptvgroup.com. At the end of the session, like mentioned before, we have a Q&A. You can enter your questions in the question box at any time throughout the presentation, and those will get answered. And now I will pass the mic to Sean to begin our presentation.
Good afternoon / morning, depending where you are. Thank you, Tiffany. Welcome to another PTV Talks, or Sean has a lot of fun showing you the things he knows how to do in VISSIM. Thanks for showing up. We've been dancing around this topic for a couple of sessions now. I think especially during the pandemic, we started to get more of a look at how we look at curbside and how things are picked up, how space is utilized, different methods, different apps, that kind of stuff. Now, the session is not going to show you how to put an Uber app into your VISSIM model that calls pedestrians to your thing. That is absolutely possible. And if I see enough interest with the session and some signups and people getting more interested in using VisWalk on a regular basis with their VISSIM for pickup and drop off, maybe I can do a far more advanced session with some advanced routing, some real-time dynamics and third-party stuff. But this is more centered around how to set up a model, how to utilize the basic features and more advanced features within VISSIM and VisWalk to simulate pickup and drop off. And accompanying me today is Bill Cisco, as you know, principal engineer. He'll be manning the questions, trying to help me out as we go along today. So let's start off today with a poll question. It should pop up for you there. Do you regularly do projects that do or could benefit from analysis of pickup, drop-off operations? That's whether you do it in VISSIM or some other product, VisWalk. Is it important to you and your daily usage?
And we're going to have a couple more seconds, so please get your answers in, and thank you for your participation in our poll questions. And
Okay,
Sean, yes,
I was going to assume that the change in the screen meant you were done, but thank you,
yes.
Tiff. All right, let's start off with the fun stuff. Because at PTV, we do have a ridiculous amount of VISSIM versions, whether you know them or not. I do recommend, I don't know where that text came from, must have popped up, I apologize. Has nothing to do with VisWalk right now. Um, I do recommend you figure out what version you have, because as a VISSIM user, it's kind of responsibility of us to know what tools we have available. We start here with VISSIM Junction at the top. A lot of people who have been customers for a really long time call it basic. If you haven't upgraded in a long time, it may still call basic. That's just basically your simple intersection analysis. We're not really talking about that today. It's not very big functional junction, excuse me, functional jump up to corridor here. With the corridor, it's more for, as you call it, long corridor analysis. So you add transit, and the public transit component is really what we need here. This is a really powerful interaction between VISSIM and VisWalk, down to how the doors open, how long it takes for people to go from the curb, and all of these things are built in. So you need at least corridor above to do some of these features, as well as some of the comm scripting, managed lanes, and those signalization features. But if you have Advanced Plus, even better. The dynamic assignment models, the convergence, the OD matrices, and some of the APIs also give you another leg up on top of that. When we're talking about VisWalk, some people do use it as a standalone. I have seen it, but most people come back to me to get VISSIM. It's designed as an add-on for either 1,000, 10,000, or 100,000 pedestrians, maximum at any one time. So that's within the model at one time. So if you have millions over the course of a day, but no more than 10,000 at a time, that might be for you. So I recommend you figure out what you have. You want to go up to your help and look at your license. Here I pointed out a few things on your screen. Here you can see your number of pedestrian license you have. You want to look at for things like dynamic assignment, that shows you Advanced Plus, public transit, that shows you at least corridor, comm interface, Advanced Plus, your different signalization features. So once you know you have that, you will know what features you can use going forward. All right. So if you want to back up all the way to the beginning, the very basic way of pickup and drop off in simulation is basically a quote unquote handoff between the pedestrian and vehicular environment in both directions. So your VisWalk handles all forms of pedular traffic, while VISSIM handles all wheeled traffic, including cycles, which I didn't have in here. And VISSIM and VisWalk is really the only truly native pedestrian vehicular model of all the models. And I say native, i.e., you know, push button and it works. They hand off perfectly between each other. So my favorite method for doing pickup and drop off is what I call the public transit method. And the reason why is because of the advanced ability to create, track, and analyze how people are getting in and out of vehicles. And it's really quite cool, and it's the only program that does this so accurately, which also in turn allows for realistic replications of the delay time due to boarding and alighting. You know, if there's a lot of people crowded, it takes longer to get in around them and into the car. If not, if the doors are all the way in the back or on the other side, if they're double parked, all of these things are relevant to the operational impacts, both to the pedestrian and the car picking them up, as well as the other pedestrians around them and the cars around them as well. And with the VisSim VisWalk interaction, you can get all of these things both in the input and the output direction. Very few users know that the buses can be switched to really any vehicle type within VISSIM or user configured. I often, when living in Europe and in New York City, would just make my own that didn't exist to add myself. So, got to ask yourself, this isn't the only method. Is this method for me? The pros, most realistic boarding and alighting. You get all the delay waiting statistics, the density analytics statistics. What this is really great for is drop off. So you can set all kinds of vehicles to drop off, and then when the vehicle drops off, it automatically creates the pedestrian and creates them into the VisWalk world as a starting point. So you don't need to be like, when the vehicle arrives, create a pedestrian. All of that has happened, excuse me, natively with VISSIM. The cons, it's significantly more demanding. The way that it's designed from scratch is that, you know, public transit has schedules, so they want you to put in the timing. In the past, we have fixed this by using flight schedules and statistical analysis. You can use attribute selection and in the past scripting to get kind of controlled distribution of vehicles based in this way, but it's really much more difficult. And there's really no way to simulate double parking or illegal standing because the public transit vehicle needs to be next to the curb. All right, it really wants me to move to the next one, so let's just go to VISSIM. Today, I'm not going to be showing crazy, amazing Detroit Airport. I'm going to be showing simple stuff. All right, so the simple, you've got a road and you've got a thing here, right? So when you create your public transit line, let's come over here. You'll see here that you have your vehicle type. You have all your built-in ones here, but I don't really want to use any of these. So let's just keep it like that for now, right? So I'm going to come in here to my vehicle types. I'm just going to duplicate this guy here. Let's call it 101 taxi. All right. Perfect. Now I've got that taxi. Here I can change the capacity. Here, VISSIM isn't really designed from scratch to be to have vehicles be carrying people in and out for some reason. So here I like to set the capacity to 1. You can do 2, 3, 4, whatever. For the simplest way, I like to just say 1. Let's just for fun also create taxi. I can go in here and I can add here. All right. I don't know what just happened. Okay. There we go. So now I have this available here. And I want to go into these 3D models. This is why I like to show this, because it requires a few pedantic changes. So I'm going to bring this. I don't see my taxi. Anyway, so then when you come in and you can change this here. And so when you run your simulation, you have the vehicles like that. See, this is the hard part. You actually have to put in your rate for it, or some kind of manual thing. All right, so let's see if that works. Let's slow it down a little bit. All right, so I didn't put in the taxi, but now you can see that the bus is a car. All right, what do we need? We need somewhere for it to stop. Let's get the transit stop there. Now we're going to add here. Okay, and let's make platform edge to the right. Okay, so with those few clicks of a button, now we have our general idea of what's going on here. So now vehicle should, yep, there you go. All right, so nothing's happening yet. So that's set up. So let's come back to that in a second. So that's how you set up a vehicle. That's simple. I know it took me a couple of steps. You can add anything you want. Some people like buses, cars, trams, Uber vehicles. I was showing you how to add that Skoda vehicle. That's the one we used in Ireland. So let's move on real quick. So before I completely set this up, this is what I wanted to show. So doing pickup and drop off, this is really the simplest way to look at it. So the imaginary line between what I just created, you can see there the PT stop in orange and the VisWalk curb waiting area there. Oh, come on. In blue. And then your vehicle approaching. And this is a two-way thing where people can pass on and off. So once the vehicle is released, once the pedestrian is released out into the VisWalk model, it does VisWalk stuff as normal. And as the VisWalk pedestrian gets to the VisWalk curb, that is the end of its journey. But once it gets into the vehicle, that is the beginning of the VISSIM journey. So that being said, that's the simplest way to think of that. So before I wanted to show that before I got into this next thing. So if we bring this back up here, okay. So the reason why that wasn't dropping anything off was because we need to go back in here and change this guy here to 1. I believe if we change it to more, it won't do anything. So let's try that again. So what do we think will happen? The pedestrian has nowhere to go, but VISSIM should still try to emulate it. Yep, there you go. All right, so they disappeared. All right, they have nowhere to go. Here comes another guy. It's using the default distribution. So it uses the distribution of pedestrians based on the faults right now, but you can edit and do that. You can see some of my old versions, or Levi's old versions there. So we need something for them to do. So let's say, all right, let's do that. All right. So now they have somewhere to go. So one thing we have Let's just make sure that's not set as a waiting area. Not a waiting area. Okay. So I need to send them there, so I'm just going to add a simple pedestrian route. And yes, I know all these examples are super simple. The idea is not to teach you every little single detail. The idea is to show you what can be done. So that should change their minds. Right, let's see. Yeah, super simple. Okay, so once you create them in that way, they're now at the curb. Oops, sorry. They're now at the curb, and what they're doing is now VisWalk. So anything you put in here, building, whatever, waiting curb, and vice versa. I have done I will do vice versa in other examples. So let's just move on for sake of time. I'm gonna take Levi's credit for my own. This model is wonderful. If you haven't looked at it, I recommend going back and seeing the old PTV talks on this model. This model is not flashy with 3D, but it shows every single possible aspect from beginning to end of how things work. In this case, Levi uses the parking lot method, which is different from the public transit method. If you see there, it contains gems such as double parking and taxi queue next to each other. And this model also has a lot more in it, which we will talk about later. But specifically, I'm pointing out the parking lot method with the double parking here. So what is the difference? They're both accurate and they're both good practice methods in VISSIM, but they're used for different fidelities, really, honestly. The public transit method is to simulate specifically the action of boarding and alighting. I have no idea why it's doing that. Whereas the parking lot method does a lot more with double parking, curbside, road impacts, pulling in and out, and that kind of stuff. And it uses attribute selection to generate cars and pedestrians. So basically, the pedestrians wait at the curb until a car comes, and then they disappear, and then the car takes off. So it's kind of like not the actual action of boarding, but to simulate both the capacity at the roadside and the on the roadway itself. Let me see if I can open that. Oops, my apologies. That model. I'll hide this for a second. So this is interesting here. So you can see the way that the parking is. So if you were to, let's run this guy. All right. So having the double parking allows for the vehicles, and the way that it's set is you have waiting times, average waiting times of the pedestrians, and you have average waiting times of the vehicles that correspond. And the generation of the different things are based on similar things. So when you do it in this way, you can see that the people are not particularly boarding the cars per se, but you're getting a more accurate curbside operations. You can see with the vehicles moving that looks a whole lot like a big city airport if you've ever been to, a whole lot more than the one I just showed you. But it can't specifically replicate this. The same with down here in the taxi queue. This taxi queue uses a parking lot method. It allows for better holding of vehicles and more accurate routing, but it doesn't show the actual boarding and alighting method. This is, let's see, yep, see, it just kind of disappears. Both methods work. It really depends on what you're looking for. I think that this is really the best way to do operational analysis. for curbside at something like a train station or an airport. And the interesting thing about that is, while this doesn't give you the boarding and the lighting statistics and the density and the waiting times for the public transit, it does allow for more color coding features and more density analytics at the curbside versus the public transit method. All right, let's just pause that guy for a second. Let's see what else fun that I can find for us. All right. Here we go. Poll question number 2, Tiffany. Are you interested in learning how to add VisWalk or upgrade VISSIM to add these PUDO capabilities that I'm talking about if you have a basic version or something, or you don't have VisWalk?
Sean, we're back.
Welcome back. All right. I've talked about this one a few times, but I like to go back to it because I feel like it's something that we use a lot and it needs to be more frequently used. So Levi actually taught me this method here for more advanced weighting. There's a common problem with pedestrian vehicular modeling, which has different names, but I like to call it gating, where opening the gate in enough time to get something to go through, but not leaving it open enough for the anomalous people to sneak through, is often quite difficult. And if you've done anything in the realms of parking lot gating or holding people with signals, you kind of know what I mean, where the hacks you use, people try to sneak in, and this is where attribute selection can really be helpful. So with the public transit waiting method, the waiting area allows as many people as you want to get to that. There's no way to hold people back from it per se. So I use attribute selection to make sure that only the appropriate amount of people approach the taxi person to get in the taxi. I'm almost using it to add a form of civility to keep people from crowding and to form lines in a more appropriate way. Here you can see the code that I used. So you can't really see the number, but the black square is 1091, and that's the waiting area for the public transit. And then 1099 is the service point selection in the queue, which tells people to only continue to the waiting area if no one is queuing there. However, service point selection can't be paused. So in the fraction of the time that it takes for the person to walk into the vehicle, the area then tells VISSIM that it's empty. So the service point selection sends the next person to the waiting area. However, that person reaches the waiting area before the public transit vehicle leaves. Therefore, adding itself to it, this is what I'm talking about, the gating issue. It's very difficult to tell people to just wait patiently and wait their turn. So in this case here, what we did was we set the waiting time at the service point selection to a really ridiculously high amount, um, maybe 999 seconds. And then whenever the waiting area is empty, i.e. either no one's waiting or someone has boarded and the next person's turn to go to the waiting area, it sets the delay time on the waiting area to 0, so people move forward. So basically, we're creating a gate, an artificial gate using attribute selection to only let people move when we want them to based on the conditions. And this runs at every time step. You can see up there under run type, you can change it to whatever you want, every hour, every second, every millisecond. I don't know what minimum fidelity you get, but do remember that the more runs that you do over time will cause your computer to slow down. So if you're doing 1,000 times a second and you're doing 100 different things, it's going to run slowly. So let's just take a quick look at that. I know I just showed you the code, but there's a few elements involved there. So if you see here, this is how you would, so to build a pickup, I said earlier I would discuss the opposite, which is pickup, which is the exact opposite, right? Here you've got your public transit stop on the roadway, and then you've got your platform edge. Here under public transit, you can see platform edge for PT stop 9. And then this is one of the things that people often get wrong about public transit in VISSIM is that you need to have a waiting area within the public transit platform edge. So you can have as many as you want, but they need to be within here. So I've got this guy here. So then let's take a look at this route for a second. Okay. Okay, so let's take a look at this guy. So here you can see I've fed him pretty circuitously through the snake queue. And then in this case here, comes through here. And then once he gets here, you can see I've set the time distribution to gate holding time. Apparently I set it to an hour. You can set this to whatever you want, the time distribution. So once the person reaches this, they will wait for this amount of time. However, under action attribute modifications, you can see that I have, here's your little prompts here. So when you're creating one of these guys, you have to pick your attributes, and then you can see construction element 99, 1099 there. So every time step, it's going to look at this and it's going to say, if the count of pedestrians on this 1099 is 0, then set the dwell time to 0, which will effectively make this gate open, and then people can go through. I know this is a weird example, but it is an example that works for pretty much everyone. So in practice, you can see here, there's my Skoda. All right, so people don't move to the next point until everything in the system tells them. So anyone that's created a queue can tell that this is ridiculously orderly compared to the native way that queuing used to work. So that's what you get in the end. This can work with picking up people in individual cars. I have done this at curbsides in Europe for regular vehicular pickup. You do have to set uh, zones, big zones for the public transit stops, but it does work really well. So let's put that on pause for just a second. Let's talk a little bit about demand generation. Going back to Levi's model, it's something that I really like from it is his demand generation codes. I don't know if I think this model was made available, but there's a couple of codes in there that what they do is they generate vehicles congruent to the number of pedestrians approaching the curbside. So basically, they're checking every time step that a pedestrian is approaching the curbside, and they will create vehicles to the appropriate area. This would be directly applicable to rideshare and other demand services, but I'm not going to go through it in this presentation, but I'd be happy to discuss it if you want to reach out to me. So effectively, VISSIM sees the code this way. Circular code doesn't really have a beginning point, but let's say that the beginning point is the time step end. So actually most of those codes were set to time step begin. So the first thing it does is it asks, it fulfills whatever code action. So let's say it's a normal attribute selection. Does it fulfill request X? If yes, then move on to do something VISSIM-y. If no, then go to the next time step. And this is constantly going, right? In the case that we were showing, it was showing that when people appeared, then it would go down here and create a vehicle and then move around. It would keep going. You can also add third-party code. This is something I used to do a lot. So external API, right? Is that ride share? Is that bike share? Is that something? So it would go here. You can add Python scripts. You can add coding. You can add external files. You can add third-party stuff. So looking back at this guy again here, you really can split it into two things. To do it to whom and to do what, right? So up here you've got vehicle inputs, vehicle input to. This attribute someone's gonna have to teach me how to turn off the timers. Attribute selection here you can see is set for vehicle input type, which is for demand generation. And then down at the bottom, you can see how the new attribute is created, right? It's looking at the max of several values. And when it's doing a table lookup, a lot of the VISSIM data is created in Access tables and Access databases in real time. So that's what it means by table lookup. So what it's doing is it's checking all the different things to make sure they match. I left in all my Star Wars references from the one in May. I can't believe it was May already. Okay. So since it cannot sit still for the life of it, so this model actually has 8 different attribute selections in it, right? It's got pedestrian generation in it. It's got arrivals demand generation for the vehicle input. This is actually the one I just showed you here. So it's looking at vehicle number 2, which I believe is the taxi input. Nope, it's 5. So 2 is up here. That's the vehicle input. So it's looking at 2, volume, and then here you've got your different tables that it's looking up. And then also you have pedestrian inputs, pedestrians and network. You can change here. Instead of using a formula, you can actually make distribution edits, dwell times, that kind of stuff. There's one here that creates a taxi when people create, right? Number 5, that's the taxi here. Right, so I recommend that you go around and you mess around with this guy. It's really fun. But you may not realize it at first when you're first looking at it. But like, for example, down here at the taxi generation, no taxis are coming. And that's because there are no people here. So what this is doing is it's actually creating the demand as it's necessary. And while, you know, it can be arguable just about how realistic demand creation relevant, whatever algorithm you use, the taxi here basically functions as an on-demand service. Many countries have this at their airports, but for us, this would function much like a ride share service, right? And in that case, what you could do would be to, implement distributions and waiting times, implement distributions and just exactly when a vehicle is created for the person relevant to when it arrives. So like some people will get their Uber while they're on the airplane. Some people will get their Uber while they're at the curbside. Some people will get their Uber while they're at the baggage. To add these different things in, and you can do scenario analysis of the different kinds. But one of the interesting things about this is whenever you try to aggregate or estimate or judge volume based on fixed demand characteristics, i.e., you put in 1,000 people and 1,000 vehicles, you'll always get some kind of weird, incorrect peaking characteristic, or vehicles waiting for a long time. Or in my case, with the PT thing, if you enter it incorrectly, the taxis will leave before the people get to them, right? These are all just inefficiencies of how they were designed. So using on-demand attribute selection in this way, and again, I do recommend you go back and watch Levi's presentation about attribute selection, does allow for flexibility in demand generation, demand expectation, and the realism of just how the two models should work together in the temporal space. All right, let's pause that guy for a second. So just a reminder here, I'm not going to talk a lot about evaluations, but I just want to point out some area measurements, do some good density curbside statistics. Data collection points can collect all kinds of vehicular data. You can trigger things like an ATR or like a ground sensor, whether it's triggering an event or whatever. You can use attribute selection to look at your data collection points. Your parking lots stuff, you can look at your PUDO operations. Pedestrian travel time and vehicular travel time can work together in concert to look at transfer times, as well as connections between rideshare services. mobility as a service, connection times, drop-off locations versus destination, that kind of stuff. With your pedestrian grid skills, you get your heat maps, and then you can do queue counters and stuff to do queue analytics. Just a couple of pictures in here. These are all native to VISSIM. These are not third-party created. You've got density at curbside for a train station. There you have pedestrian density analytics for volume. These can all be viewed while the simulation is running in real time, and you can get different video outputs and stakeholder to get kind of more of a realistic idea of your space at your curbside. So what we're going to do is we're going to finish up with one last poll question. So Tiffany, do you feel that VISSIM and VisWalk has the features you need currently to be sufficient for your curbside management project or analyses? Well, this is a yes or no question for my benefit, and yes, I will see it myself. Feel free to reach out to me personally or anyone else on our team to give a why for your answer. We do have weekly talks with operations, management, engineering. We guide the pipeline, and customers, especially people who come to our UGM and meet our team in person, drive the future of our product. So we do want to hear back from you about what you need, what we have, and what we don't. Since I have control again, I'll assume that that's over. So I'm going to finish up and just say thank you for your time. I've been Sean Fitzgerel. I am the Senior Account Executive for VISSIM VisWalk Mobility, as well as the subject matter expert with about 20 years of experience in microsimulation, especially PTV products. Feel free to reach out to me. I'm joined, of course, by Bill Cisco, our Vistro and our engineering expert. You can reach out to him as well. I think he's either been or will be answering questions and providing me some questions as well.
Yeah, for sure. Thanks, Sean, for the presentation. We have some questions queued up here. If you're ready, we'll start on those.
Sure.
Perfect. So the first one, and I'm getting echoes, so I'm just going to plow through it. But how do you make vehicles pull in 100% into the PT stop? The person says they have transit stopping at an angle, and they wouldn't pull in 100%. So they take up 2 lanes.
Okay. That's one of those questions that started off one question and one expected answer and came up with a different expected answer. So when you said pull in 100% of the time, I assumed you meant that they're not skipping, which I don't think that's what you meant, but just in case, I'm going to show that for people who don't know. So these demand lines are actually, so if you have multiple vehicles going through here, and you right click on here, you can actually see PT line 1, stop 1, pass 1. So like if you're doing, you know, so you don't want skipping to be possible. You can change a lighting percentage to 100% minimum, all of that stuff. However, if you're talking about the second question, which I think you have, that has to do with a lot of things. It has to do with sight distance. It has to do with lane change distance. It has to do with vehicle distance. So vehicles that are created on a link need to have the correct amount of time to change lanes and to have knowledge, right? So if you're like way back here and they're created up here, they won't have enough time to understand where they are, and then they'll just jut over. Also, if they're a long vehicle and the stop is about the size of the vehicle and you have multiple lanes, sometimes they'll just go at an angle. That has to do with like lane change distance parameters. If you want them to be straight at the curb, they have to already be in the lane by the time they reach the transit stop. If they need to be 100% perpendicular to the curbside, that's probably a calibration parameter. So I
Perfect,
answered
thank
two
you.
questions, so hopefully one of them was the right one.
Yep, I would assume so for sure. Second set of items there. Perfect. Okay, next question. Is there a potential to provide more random arrivals for pickup drop-off vehicles rather than a determined schedule? And the second statement says it would be preferable to show peaking characteristics that are variable to reflect event conditions, for example.
Yeah, so if you're talking about the public transit method, there are a number of methods. You can, in the past, we kind of, so when we were doing airport work in Europe, we used a schedule of flights where you had percentages of people arriving over time. So we kind of created peaking characteristics in Excel and put them over into the arrival and departure times. So that is really good for something that's predictable. Well, you know, flights, trains, school, that kind of stuff. For unpredictability, I worked with Jacobs in Europe, and they had a Python script that would randomly introduce buses by changing the schedule over time. I would have to defer to Levi. I don't know if he's around today, but as far as attribute selection, I assume that using an appropriate attribute selection, you could probably also introduce the kind of randomness that is similar to the patterns I showed with the demand generation tool in his model. But if you're using the method with the parking lots that doesn't have the direct get on the bus through the door, you know, the second method I showed, that uses the standard vehicle input demand generation that VISSIM uses. So there are two approaches to the same problem.
Thank you. Next question, is there a PTV recommended list of driving characteristics to mimic aggressive driving behavior at, for example, airport curbsides?
I can't say that PTV VISSIM has a curbside thing specifically. There is aggressive, medium, and less aggressive driving behaviors, as well as quite a bit of significant research into different volume calibration. What's the word I'm looking for? Like value ranges. However, since PTV is a global corporation, and literally not only does every country have different requirements, driving styles, calibration tools, but every city, country, state does. So we don't particularly have a set of recommendations, but most communities or DOTs will, or they will default to whatever the default in PTV documents or in the federal level is. We also have medium, aggressive, and not aggressive connected and automated driving behaviors as well.
Cool. Question, is it possible to model pickup and drop-off areas with mixed parking area configurations? For example, parallel and perpendicular parking, one on each side of the road.
Yeah, so the version 23 and on had introduced quite a bit of significant backup and perpendicular and parallel parking. You can set those up on both sides of the street in whatever configuration you'd like. If you're going to use perpendicular and parallel parking, you'd probably want to use a method like Levi's, where you have a demand generation tool not related to the public transits through attribute selection. So you would build all of your parking spots. You would have your roadway system, and you would have your parking, your parking routes and your parking routing decisions. And then you would need to have areas along both sides of the road that generate demand based on the parking. And basically, I imagine the way that it would work is it would check every time step whether the parking space was full, like if someone had come into it anew, and then it would generate a pedestrian. This would all be fairly simple and stuff we could do in standard support queue. So yeah, I haven't seen one personally, but I think it would definitely be fairly easy.
All right, perfect. Well, with that, we're within a minute or so of the top of the hour, and if there's any additional questions that come in, we'll follow up with those via email separately. Otherwise, Tiffany, I think I'll hand it over to you to close us out.
Yes, this is the end of the session for today. Thank you for participating and thank you for joining us. As a reminder, there will be a recording of this session sent in a follow-up email. If you have any questions, feel free to reach out to either Bill, Sean, or me at marketing.us@ptvgroup.com, and have a great day.